2018, Elon Musk said the upcoming Tesla Roadster would be available with a SpaceX package that features thrusters for an acceleration boost. Since then, Tesla has focused its efforts on other vehicles, like the Cybertruck, and we've yet to even see the Roadster reach production. That's why in late 2021, YouTuber and engineering whiz Matt Mikka developed his own boosted Tesla. He added 3 jet engines to his Model S, built the electronically controlled engine system from scratch, and created what is probably the only Tesla that can burn through 2 gallons of fuel in just 1 minute.
So what inspired that project was that Tesla said they were going to do these like cold thrusters, basically like high pressure compressed air. But the issue with the cold thrusters is that you need a lot of energy to compress that air to a pressure that's useful. What a lot of people don't realize is that cold thrusters don't actually have a lot of thrust. One of those engines I used on the Tesla project was about 350 newtons, and a cold thruster isn't going to give you anywhere near that.
Besides building 3 different engines, Matt had to build the proper jet engine control panels, including a setup for the driver that connected to the rear controls. This meant a lot of wires, electrical outlets for the wires to run through and plug into, and individual circuit boards for each engine to connect to. But most of the engines themselves were wireless.
I don't want to give away all the secrets here because I actually built that system from scratch. Most of those jet engines use a digital signal. Digital means 1 or 0, on or off. So I had to figure out a way to take that human input and that movement and convert it into a digital signal. Do some coding, write some code, and it actually worked.
Matt's Tesla project also involved a ton of metal fabrication to create parts. For this, he turned to his trusted water jet cutter.
So the water jet I have uses high pressure water with an abrasive to cut pretty much any material except for diamond and tempered glass.
No matter how complex his work gets, Matt never skimps on presentation.
In that particular build, I wanted to do the lettering and the switches sort of like a fighter jet. So if there's any pilots that are watching, they look at that and they're like, oh wow, that looks like the same type of thing I have in the jet that I fly, where I can feel the letters. I did like the raised letters. That was one of the toughest parts of the whole build, was to make those panels. So I basically made the panel, I had to clean it perfectly, spray it, bake it, throw it on the 3D printer, clearance the 3D printer perfectly in order to write just 2 layers of material on there, have it stick, and then clear coat this whole thing to make it look like a fighter jet sort of look.
Next came mounting the jet engines, which is not an easy task when it comes to Teslas.
They're all aluminum. The whole car is aluminum. So it's really tough to attach anywhere on the car because it's just not made to hold any weight. The good thing about Teslas are they're pretty modular. So the whole car is basically 4 parts. The body of the car, the high voltage battery, the rear drive unit with the subframe that all comes down as one piece, and the front drive unit with the subframe. So what I did is I just attached the subframe underneath.
After mounting the engines, Matt needed to give them a fuel supply. So, naturally, he filled the frunk, that's a trunk in the front of the car common on electric vehicles, with a fuel tank that can hold up to 100 pounds of kerosene. The engines are also capable of running on hydrodiesel. The entire project cost him $15,000. With everything in place, Matt put his Tesla's thrust to the test. After achieving a 0 to 60 time of 4.38 seconds with EV power only, his second run with the jet engines blasting was over a full second quicker. For reference, Matt says he managed 0 to 60 in 2.4 seconds without the jets, in perfect road conditions.
I do have a schedule to keep, so I couldn't wait for a week for a dry day, and it was also cold, but I was really impressed with how much it reduced my 0 to 60. That was impressive.
He even took the car on the highway, threw it into neutral, and reached 61 miles per hour on the jet engine's power alone.
So if I did this again, I would definitely go bigger, and I would find a better way to attach it to the car. It just wasn't enough thrust for me to make a difference. I mean, it was cool to prove sort of thrust can actually reduce the 0 to 60 time. That was pretty interesting.